All right, so we're going to factor this completely and then sketch a graph of this from the basis of what we know right now. So when we factor completely, we always look for a GCF first. So if I look at all these terms, they all have something in common. They all divide by 5. And they all have x in them. And if I look at the smallest x, down here this x squared is the smallest amount, so I can't take out any more than I have. So let's divide each of them by 5x squared. So we get a 2x squared plus 5x minus 3. Just to double check, you might kind of want to look to see if you distribute that 5x squared, do you get back to the original? Okay, if you aren't, then you did something wrong with it. And also, if I look in the parentheses, there's nothing in common. I do like to check my powers too, so I have a squared, an x, and no x. And so it just keeps, if I keep with those systems, I can notice if I make a mistake, if I leave a power out, just that organization can really help. So now I'm going to factor inside here, if I can. I'm going to use a box for this because it seems like it's a little bit more difficult factoring for this. So a 2x squared and a negative 3. I want it to add to be that middle term of 5x and multiply to be this product of these two right here. So this 2x squared times negative 3 gives me a negative 6x squared. Okay, so factors of 6, I could have 1 and 6 or 2 and 3. I'm going to have one of them negative and one positive. And so to get this positive, I'm going to make the bigger one positive. Oops. And so this would be my combination. So a negative x and a 6x is what I'm working with. I can pull out an x horizontally. Vertically, I can pull out a 2x. And those do multiply to give me that 2x squared. And then if I look in the last one, I can pull out negative 1. Or also x times negative 1 gives me that negative x. And then 3 is in common. So now my function, all factored out, is 5x squared, 2x minus 1, and x plus 3. I set each of those factors equal, so it's completely factored. Now I find my zeros. So 5x squared equals 0. Divide by 5, still have 0. Take the square root, still have 0. 2x minus 1 equals 0. I'm going to add 1, divide by 2. And then x plus 3 equals 0. This gives me negative 3. That one might be an easy one to do in the head. Right, so 0. Let me put a little scale here. So I'm at 1/2, pretty close there. And then negative 3. If I look at any bouncing here, I do see I have that 5x squared. I am going to have a bounce here, so right at 0, there's going to be some kind of bounce. So I like to put a little circle around that to help me when I'm graphing this. And then if I'm looking at leading coefficient being positive or negative, and I can see right at the very beginning, like if this is an order, this is positive. Also here I see this is positive. This is going to end up here. So my graph, I'm going to, again, start on this right-hand side. I'm going to go through at 1, and then I have to bounce at 0. I have to go through at negative 3. And that's my rough sketch of what I would have. And let's try the second one. So let's see if there's anything in common. And these both of them divide by 3 and by x. And then also, I would take out a negative because it starts with negative. It's easiest if this first term is positive. So take that negative out, and also it would help us to see our leading coefficient. So when I divide that first one, I get a positive 4x squared, and the next one I get a negative 1. You're always going to get some kind of number. It's not 0. So, and also too, if we distribute, we have to be able to get 2 terms as an outcome. So in this parentheses, I look to see if I can factor any more, and this is one of those difference of squares. So for this one, I can split this into 2 identical factors, except one says plus, one says minus. Splitting up the 4x squared, I'll have 2x and 2x, plus 1 and minus 1. So let me set each of those factors equal to 0 to find my zeros. So negative 3x equals 0, so x is going to be 0. Whenever you take out an x or x squared, anytime there's x in every term, you're going to have a 0 at 0. And then we'll set these equal to 0. So I get this fraction of -1/2. And this one I'll get a fraction of +1/2. I'm going to make a little bit bigger scale here. So I'm at 0, -1/2, and +1/2. Now there's no multiplicity with this. It's going to run through it. If I look at this negative leading coefficient, I'm going to be ending down over here. So when I graph, I'm going to start through here. I'm going to just go through each of these points. I'm going to go through the 1/2, through the 0, through the -1/2. Okay. This B has a degree 3. I see my ends going opposite directions. That's what I would expect. And for A, that degree is 4. My highest power here is 4. And I see the ends going the same direction. That's what I would anticipate. Okay, so to make sure you factor these completely, remember that if I look at this form right here and this beginning, these are identical. They're just written different ways. Again, this one and this one here are identical. They're written different ways. I can see my x-intercepts when it's in that factored form. Not all polynomials will factor, especially factor this easily, but if we can factor and find out those x-intercepts, we know a lot more about our